So thank you everyone for being here. We're going to have a small chat about how can AI improve the measurement practices and how it's revolutionizing in general the development industry. So how can we convert ourselves into the intelligent metric experts? As Pierre introduced me, I'm Gonzalo Scanferla. You can find here my contacts if you want to make any questions. And you have also a QR that you can scan to try LEDAS tool Quanter for free. As we are all familiar with AI tools in the latest years, we introduced a set of new tools that are multimodal and that allowed us to make magical things like starting from a picture and a simple prompt to convert ourselves into a Studio Ghibli image, or make ourselves something more futuristic or something more photorealistic, even though it's probably an improved version of me. But we all tried and used in our daily lives these tools, but how did we get here? It all started more than 60 years ago. Artificial intelligence is not coming from the last recent years, but it started for the first time. The term artificial intelligence was used in 1956 when McCarthy team of experts met to debate about the creation of machines that can execute human tasks. From then on, the definition of the theoretical boundary started at the beginning with the mathematical theory, with the establishment of the first artificial neuron and its mathematical basic concepts like activation level, function transmission. Then for a long time, the artificial intelligence didn't make great leaps, either from one side because of the computational limitations, and from the other side because it was focused on creating and programming a semantic description of the world and of the environment, and all the possible cases that could happen, and so the computer could respond to all the possible cases. But then in the 90s, a new way of thinking started, and the new AI started, and it was based on interaction and building the image of the world based on sensors input and from any kind of input that the AI could have. From then on, things started to change rapidly, also because of the technological evolution. In 1997, as we all know, Deep Blue defeated for the first time the world chess champion Kasparov. But it wasn't until 2012 that we had the next giant leap. And this giant leap was when AlexNet won the ImageNet context by introducing GPUs for the calculation. And this was a big step forward, especially for the resolution of matrix calculus. From then on, the events and the evolution started very fast. In 2016, AlphaGo defeated Lee Sedol in the Go game, the World Go champion. In 2017, we had another giant leap that it opened the doors for large language models when Google introduced the transformer architecture. So introducing a new approach to the natural language processing, and opened the door for cross-domain applications. So now we could interact with natural language with artificial system to work with cross-domain capabilities. So in 2020s, the era of large language model, exploded with the release of GPT-3, and where for the first time a large language model was capable of performing tasks it wasn't prepared for. So since until this moment, we had responsive artificial intelligence, but now reactive artificial intelligence, but now we enter the world of the creative artificial intelligence. And so it's what we have right now, that is the generative explosion, with systems that are not only capable of answering questions or solving problems based on their training, but also to generate new information that wasn't existing before. The most well-known models we are using right now are like, some are more specific, some are more generic. There are hundreds of them: Copilot, Stable Diffusion, Sora, Midjourney, and Quanter is one of them, and it's specific for functional estimation. As Arthur C. Clarke, that was a science fiction writer who wrote in 2001 A Space Odyssey, any sufficiently advanced technology is indistinguishable from magic, because the leap forward and the capabilities it has seems magic to the common people. So AI, it's already in our daily lives, and it's already changing the software development world. It has been massively introduced in most companies, and we already have studies from different consultants that are giving the first results about how it's impacting the software development. There are different numbers. Not all of them have the same results, but they all agree in the fact that artificial intelligence can improve drastically the productivity of software developers. And this productivity increases more in all the simpler or more mechanical tasks, like documentation or the generation of low complexity code or refactoring, and the improvement is higher if we have junior users. But how could AI help metric experts? The first step is to define what is the task that we have to perform, that is functional estimation. Functional estimation can be performed for two different reasons. The first is for estimation of the effort that is required to create a specific program, and calculate hence the cost that will have this development to be completed. The other goal can be as a standardizer and as a comparison unit for benchmarking with different technologies, different teams, and different groups or vendors. So the first limitation that we can find in these two main tasks is that the effort that we can dedicate to the estimation itself and the resources that we can dedicate is limited. So we have a limited sample of projects, either because we cannot estimate all the projects we have, and because we rely on the projects that have been developed previously by our company. On the other side, the other main problem that we face is that when we make the functional estimation, usually is in an initial stage of the development, but we don't have a lot of data or specific data for the non-functional estimation, even though we want to include it because it's an important part of the estimation. So we have a limitation because we don't have enough details for this non-functional estimation. Then also, most of the times, the requirements that we receive, either from the PM, from users, they are neither complete nor well written. So they can be misleading, they can be incomplete, so some functionalities are not estimated, and then we find them in a second stage of the development. So this is also another huge problem that we face when performing a correct estimation of the projects. And as an estimators, we want also to add more value to this chain. So what can we also provide other than a number saying how much this development will cost? So how can AI help us with these points? The first of all is requirements. Requirements is the first step. So if AI helps us to have well-written requirements, and all the information is complete and comprehensive and standardized, all the work that is coming before will be more accurate and will be faster, and everything will come easier. Then AI can help us in having an estimation draft according to statistical data, and using statistical data of other projects. It can also offer us a non-functional estimation of similar projects with similar technologies in similar domains. So it can give us an initial estimation of non-functional efforts. And since all these three steps are faster, we can increase the volume of projects that we can estimate with the same amount of resources. And finally, we can add more value, for example, like adding test cases. Since we have well-detailed requirements, and we have in the estimation, we have all the functionalities, we can also define a battery of a set of test cases to be tested. So to do so, we need superpowers. We need to become an intelligent metric expert. Intelligent metric expert is an expert who uses intelligent applications. As Gartner said in their study and their tendencies for the technology, the trends for 2024, at number 7, they said the intelligent applications are in the top 10. And what is an intelligent application? An intelligent application is an application who enhance the capabilities of the users by introducing the AI in the loop. And it's important, this concept, because we are talking all the time of human in the loop. It means that users are not excluded, but the AI is needs supervision, and the users receive draft solutions and improve and correct the responses given by the artificial intelligence. So it's an improvement loop that AI offers a solution, then the users can check and correct and improve, and then repeat the loop to obtain the optimal response. So as IBM report says, AI won't replace people, but people who use AI will replace people who don't. So what is needed to create for the development of intelligent applications? The first step we have to make is to choose the correct large language model. There are several in the market. Some of them are open source, some of them are proprietary. So we have to choose the right one for our needs. Then we have to choose if it will be locally deployed or cloud. There are several options that can be and that can be made. Then this large language model must be tuned, and the fine-tuning must be done for the specific task that we have to perform, because in this case, we want to write specific functional specifications to have the requirements, and we want to have functional estimation. So we have to train for the specific task a language model that is usually generic. And then finally, once our model is ready, we integrate it into an application who gives an interface for the user to interact with it. So when creating this application, we face several problems. The first, of course, as we said, is the choice of the large language models. The second is to have the right training data set. So we have to avoid biases. We have to generate the necessary number of examples to cover all the possible different kinds of projects and the technologies that are needed, and to obtain the correct outcome. Then we have to make sure that the data is secure, because we don't want a company, when making specifications, can share confidential data. So we must make sure that this data is correctly protected. We have to make sure that no prompt hacking is possible. Prompt hacking is the fact that a user can insert a prompt to receive restricted information or to obtain answers that the model shouldn't give, like private information, like introducing hacking code into the system. So we have to avoid prompt hacking. The model have to be deterministic. So if we try several times to give similar instructions to the system, it has to give similar responses. It cannot give random answers. It has to be trained in different languages so users can interact in their mother tongue. And we have to prevent one of the biggest problems that generative artificial intelligence has, that are hallucinations. So the creation of answers that are realistic but not real. Okay. So in the case of Quanter, how these problems have been tackled. The choice of LLM was OpenAI from ChatGPT. Now it's working with ChatGPT 4.0, since it's one of the biggest and best performing language models. That the set of examples includes over 800, between 800 and 900 fine-tuning examples for the fine-tuning of the LLM, covering all the different possible types of projects. Then ChatGPT Enterprise guarantees the data security, since they don't share the data with anyone outside the company. And also the data is destroyed after a couple of weeks, I think. So to prevent the risk of information leaks. There have been several techniques for avoiding prompt hacking have been deployed. So like reinforced human feedback, adversarial training to block and avoid the large language model to give undesired answers. We verified all the answers to check that they are deterministic, but it must be creative by nature, because starting from a very simple requirement, it must be able to suggest an extensive requirement. It has been trained in several languages, and the model development produces less than 100% of hallucinations. There is tuning temperature codification that has to be fine-tuned to obtain deterministic results, but being creative, but also preventing hallucinations and finding the correct spot. So as in the functional estimations, we need some superpowers, we said. The first superpower we need is supervision. Supervision is to obtain the capability to create AI-enhanced requirements. So starting from a very simple requirement that can be an input of text or given by the user, we need the system to recommend a possible extended requirement. But we don't want only to have this suggestion, but we want also to it to be compliant with some specific criteria. For example, with the SMART rule, to be specific, measurable, achievable, relevant, and time-bounded, or to comply with ISO standards. So the model will have to justify to follow these guidelines, and also to justify why it's proposing a specific enhancement. And then the way to improve the user's job is to make questions. So the system has to make questions that can help to refine and to have more accurate requirements. So this is a loop that can be of improving the requirements, the initial requirements. Once we have the correct requirements, we can start with the second step, that is AI estimation. This, since we have very well written and standardized requirements, AI can easily perform a draft estimation. So starting from the requirements we created, or taking them from another input, also everything can be standardized to Jira or Jenkins standards. So it must be fine-tuned to accomplish, to follow these guidelines. Quanter is able to estimate and to give a first hint that must be then controlled by the expert. So the expert checks the initial estimation and can correct the results according to its expertise. And what is the final result? Is that making studies of people using AI enhanced estimation, the number of function points that could be estimated in the same time multiplies by 3 in senior users, and up to 8 times in junior users. So we have faster work and more accurate work. And so we can improve all the aspects of our estimation task. And finally, since we have all the details of our development completely clear, we can develop the AI-generated tested cases. So these test cases are, we have a first set with all the objectives and preconditions. So the functional estimation also can be done in different standards using function points, fast function points, snap, NESMA, so it can be also tuned for several several methodologies, and it can be in the future trained for more. And so I was very fast. I think I'm finished my presentation, and I thank you very much for attending. And if you have any questions, you can make them, or you can send them by email, and I will be pleased to answer them. What about AI biases or incomplete information about data sources used by LLMs, AI, to derive estimations? Yeah. So to avoid biases, the most important part, as said in the training, is to have a comprehensive data set. We have to cover and use all the statistical tools that we have available to avoid incorrect responses. Of course, AI, either Quantar and any other AI tool, can be wrong. If you use Copilot, for example, any answer that Copilot gives on the bottom says AI is not a perfect tool and it can make mistakes. That's why we need the person in the loop. That's why we need the user to be there and to check the responses. Okay, so AI is not replacing the expertise of the person. It's simply improving its accuracy, since it's making questions that probably at some point, if we are working, we haven't thought about, and also making the dirty jobs. So we don't have, for example, to write all the requirements and make and define all the inputs, the outputs, and everything, but they are all already in the list, and we can check them according to the result we want to obtain. So it's very important that we don't forget that these tools are here to help our job, our daily life, to make it easier, to make it faster, but they don't replace at all the expertise of the user.
Thank you.